So we have a couple of different tags that we're using. We have the standard acoustic tags. Those are smaller tags. They're called Vemco V16 tags. Those go inside of the animal, in this case a shark, and they transmit a unique coded ping almost that we can't hear, but the hydrophones that are in the water can hear those. We're also using satellite, pop-off satellite tags, known as PSAT tags. So these tags are attached on the outside of the shark, and they estimate the location of the sharks based on the amount of sunlight, basically, so the day length, which can give you an idea of latitude, and then also the geomagnetism of the Earth. And using those parameters, you can estimate the location of the shark while it's underwater. So when you bring it all together, you can get kind of a broad spatial and temporal idea of where these sharks are at different times of the year. So when the sharks are in our bay and in the Delaware Bay and in and around coastal receiver arrays, then we know whether they're there or not because we have those the transmitters in them, the V16s. But then using the satellite tags, we also get an idea of where they are when they're not around these receivers. We can, if they go offshore where nobody's listening for them, we can know that. Or if they just go in between these coastal receiver arrays, we know that too. And then using the VMTs, the tags that both transmit and receive, then we can get an idea of what sorts of animals are also around these sharks. Are they only ever encountering other sharks? Do they kind of hang out in groups? Do they not? Are they alone most of the time? Do they hear striped bass or sturgeon? Are they migrating the same pathways as these other economically important animals? So those are the kinds of things that we can get from this information, and kind of tying it all together to figure out where are they going throughout the year, what is their migration like, what sorts of areas have big congregations of them that maybe we should try to protect or research more than other areas when they're more spread out. You know, you have a 8-foot shark in the water. We always keep them in the water, and so you have an 8-foot shark alongside of a boat, and you're leaning over this boat to do a surgery, basically. I mean, it doesn't take that long once you get the hang of it, but if the water is rough, then you're just rocking back and forth. It gets a little crazy at times. So Otis is really exciting because it's the first time when we've been able to really see where these sharks are when they're not in the receiver arrays in the bay or along the coast. And we get to see it in pretty real time, which is pretty cool. So, we were watching how the environmental parameters, how the water color was changing, or how the temperature or salinity was changing, and whether or not that meant anything for whether or not we would find sharks or not. It's really cool to be able to really, in real time, tie together the in situ environmental data from the water and in a 3D sense. So in a X, Y, and Z, we're getting these profiles with depth, which is something that it's hard to get out in the ocean.